Hello all, welcome to Code Hub. Today let us solve the LeetCode's daily challenge, the combination sum 4. Given an array of distinct integers nums and a target integer target, return the number of possible combinations that add up to target. Return the number of possible combinations that add up to target. Okay, the test cases are generated so that the answer can fit in a 32-bit integer. So this is the nums array and the target is given as 4. We have to find the number of possible combinations that is going to add up to 4. And we can see that this 1 itself is used 4 times to make up the sum of target 4, and this 2 is used twice to make up a sum of target 4. So what it means is we can use this each element in the array infinite number of times to make up the target. So we have to make up the target with the given number of given array. So what it is meaning is, given the array 1, 2 and 3, we have to form this target as 4. So we can have 1 plus 1 plus 1 plus 1, or else we can take 2 and 2, or else we can take 1, 1 and then 2. These are the possible combinations that we can take. So there are 7 possible combinations, so we have to return 7. So for this obviously we have to go for all possible combinations, and we have to surf through all possible combinations. So we will be doing it in recursive manner, so that we can go for all possible combinations. So let us define a function. So let us define a function. Name it. I will name it as get all possible combinations. So this function is all possible combinations of nums and the target. So this function is going to return me the target, return me the all the possible number of combinations that is going to make to form this target. So this is my recursive function. So let me define the recurrence relation so that it will be more clear what I'm trying to say. So let me express all the elements in the array to be indexes. So I will also pass the index, pass the index 0. So obviously from I can go, I'm having an index as 0, 1 and 2 in this array. So I can represent them it as indices. Mm. So we have to add one condition here. If my nums of I is going to be lesser than or equal to target, then only I will be decrementing this nums of I with the target, or else I will not be doing. If my nums of I is greater than target, then my target becomes less than 0. So this is the one case I can check. And these are the two cases, and if I say this as option 1 to be this, and this as option 2, then finally what I will be doing is I will just return my option 1 plus option 2. And what will be the base case here? The base case will be nothing but if my target, if my I is reaching the end of the array, if my I is reaching the end of the array, then what I will be saying is return target equal to 0, or else if my target is not 0, then obviously I will not be making this combination that which sums up to target. If my target is 0, then I will return 1, else I will not be returning 1. So this will be my base case. So let us code this approach and then let us see whether it is working or not. I will name this function and I will just return this function. The passing parameters are nums, then target, and then the index 0. Okay. So I will define the function. This is going to return me an integer value and vector int nums, then a target int target and the index I. If my I is going to reach my index nums dot size, then what I will be saying is return target is equal to 0. Else what I have to do is I have two options. Int option 1, which is nothing but get all possible combinations nums and target. First I will define those function to be 0 and option 2 to be 0. If my nums of I is going to be less than or equal to target, then what I can say is option 1 is nothing but nums target minus nums of I. I am picking this element and I am just staying in the current index itself. Or else what is my option 2? Get all possible combinations nums. I'm not picking this element and I'm just moving to my next index. And finally I am just returning my option 1 plus option 2. Let us run the code and see whether it is running or not. It is returning 4. Let us see what is the mistake that I have done. Actually, why it is giving the output is 4 is it is nothing but I think it is counting this as one possible combination, this as one possible combination, and this 1 3 as one possible combination. 1 3 will be forming in one possible combination, and 2 2 will be forming in one possible combination, because this is going forward, and if it picks 1, then it is not it is going to pick 2 or 3 only. If it is going to pick 2, then it is not if it is going to pick 2, it is not going to pick this one, and then this is not going to pick 1, because we have written a recursive code which is going forward. If this picks 2, then it is going to go forward, so we have to change the recurrence relation itself. Because 1 1 2 and 2 1 1 is a different combination, it is not same. They have given here note that different sequences are counted as different combinations. So we have to change this recurrence relation alone, and let us rewrite this recurrence relation in for loop, because if I'm taking this combination again, it starts from the 0th index. If I'm picking this 2, then again the next element can be started from this 0th index. Again if I'm picking this 3, it can start from this first index. As you can see, 3 and then 1 is one combination, 1 and 3 is and then one combination. Our recurrence relation will be going only forward, we will not come back and take that. So we can run a for loop index j equal to 0, j less than nums dot size, which is n, size of the array, and j plus plus. We can have one variable answer which is initialized to 0, and we will be adding up to our recursive solution, where if I'm picking this solution nums and then target minus nums of j, if I'm picking this picking this case, then what I will be passing the index. If I am picking this target minus nums of j, then I can again start from j itself. So in this case, I think we don't want this index itself, because our base case can be as simple as this. If my target becomes less than 0, then I will be just returning 0. If my target is equal to 0, then I will be just returning 1. So finally this will be accumulated with our answer, and we will be returning our answer. So I think we don't want this index variable itself. So this will get all possible combinations with different combinations as well. Like 1 1 2 is one combination, even 2 1 1 is also one possible combination. Consider I will give a dry run so that you can visualize and see. I am calling this function with nums and target. Initially target is nothing but 4, so I am coming inside this loop. Target is not less than 0 and target is not equal to 0 also. So my answer variable is initialized to 0. Then I will be running a for loop. Visualize it. Then this j index is going from 0 to nums dot size, and j is plus plus. Answer plus equal to get all possible combinations. This function is called with nums minus, sorry, nums comma target is 4. 4 minus nums of j is nothing but 1. 4 minus 1, and this function is again passed with the parameters nums, and target is nothing but 4 minus 1 3. So now my target is 3. So 3 is not less than 0, 3 is not equal to 0, answer is initialized to 0, and then I am running another for loop in that recursive call. Please note that point, that target is 3. With that recursive call, we are running a for loop. So and the get all possible combinations nums target minus, again the j is 0, so the nums of j is nothing but 1. So 3 minus 1 is 2. Again the function is called with nums and 2, and 2 is not less than 0, 2 is not equal to 0, and answer is initialized to 0. Then for int j equal to 0, again the for loop is running. 2 minus 1, 1 is passed in that next recursive call. Again if 1 is not less than 0, 1 is not equal to 0, and again 1 minus 0, 0. Now our target becomes 0. So target, since target is 0, we will be returning 1. When we return 1, this for loop has executed for when j is equal to 0 only, and we have passed 1 minus 1 0. So next j becomes 1. J becomes 1, nums of 1 is 2, so 1 minus 2 becomes less than 0. 1 minus 2 is nothing but minus 1. Target is less than 0, so we will return 0. Next the j will become 2 0 1 2, second index, so which is 3. So 1 minus 3 becomes minus 2, which is less than 0. Again it will return 0. Now our answer will return 1. So now we have found one possible combination, which is 1 1 1 1. After that it will go back. We have called a recursive call from 2, which had become as 2 minus 1 as 1. So next again the jth index will become 1 now. So jth index will become 1, and nums of 1 is nothing but 2. So target becomes 2 minus 2, and we will call to a recursive function 2 minus 2, which is 0. So target becomes 0, and we will be returning 1. So this is how the backend recursive approach will go. If you didn't understand, again go back before 2 minutes what I have said. Listen carefully again and visualize it. You will definitely get the what I'm coming to say. And just we can try to run our code. Sorry, the semicolon, I have missed it. Sorry. Okay, it got accepted, and we can just run our code. Okay, it got accepted, but anyways this is not a optimized solution, so we have to define we have to memoize the solution since there will be overlapping of problems. And how we can memoize it, we can define a DP array. So we can define a DP array of size target, since we have to form the target only, right? So we will be having a size of target, DP of target, and all it is initialized to -1 initially. And I'll pass this dp to our function and this dp here, and then here also vector int with ampersand dp reference. And after this condition, if my dp of target is not equal to -1, then what I will say, I will just return my dp of target. If it is already computed, I will be returning the dp of target, and I am just caching the solution here. dp of target is my answer. Let us run our code once again. Let me see what is going wrong here. Yeah, why it is going wrong is we will be accessing dp of 4, but we will not be having a index dp of 4 itself. So we have to initialize dp of target plus 1 index. Now I hope it should run. Yeah, it is running. So let us submit the code and see whether it is accepted or not. It got accepted. Hope you understand this solution. Let us try to convert this memoization solution to tabulation also. So this memoization solution is what is the time complexity here? The time complexity of this memoization is order of n, and the space complexity is also order of n. Order of n, which means n is equal to target. So order of target we can say it as. And to convert this into a tabulation method, it is nothing but we have to initialize it to 0, and we have to run the for loop from 0 to n, right? 0 to target. Here we are actually running a for loop from target. Target is going to be reduced till 0. So what we will be doing is we have to run a for loop int, let me say it as int sorry, in target which is coming from t to 0. So I will be running from 0 to target. So from 0, target is less than or equal to t, target plus plus. So what I am trying to do here is my target was going in my recursive solution, my target was going from t to 0. So in my tabulation, as it should go from the opposite manner, which is 0 to t. So t is nothing but my target. Just I have converted this, replace this target variable with the t. So dp of t plus 1, I should initialize the dp array. And what will be the base case? Dp of, when my target is 0, it should be 1. I should return 1. So dp of t, dp of 0 is nothing but it is 1. Then I can just start from target from 1 itself. Then I should just copy this recurrence relation from here. So I can take this dp, then I can replace this function name with this dp array, and then I can make this as long since it is a 32-bit long answer as this, and then dp of target as answer, and finally I'm just returning dp of target is nothing but t, and just as simple as that. We have converted this memoization solution into a tabulation form. So let us run the code now and see whether it is passing the test cases. Okay, what is happening here? Correct. Actually, there was a case if my target is less than 0, I'm returning 0. So we have to check the same case here. If my target minus nums of j is going to be greater than or equal to 0 only, I should add this to my answer, or else I don't want to add that. So yeah, it got accepted. Let us submit the code. Here, what is the time complexity of this solution? It is nothing but order of target into n. So order of target into n, and the space complexity is order of target. So hope you understand the recursive solution, then the memoization solution, then finally we have done the tabulation form also. Hope you like this video. Let us see in tomorrow's LeetCode daily challenge. Until then, bye.